and she's doing a little bit different than you did last time you told me. And it's also a premiere for us because it's the first Linux notebook that we have at ScriptConf. And yeah, oh. and our AV guys tell me that they get a signal to record it. So yeah, I'm excited for this talk. I'm really looking forward to what we're going to see. So give it up for Anna.
Okay, hi everyone. Yeah, so as I was introduced, I'm going to be doing something different than I did the last time I gave a talk with this title, and I'm actually going to do something that I'm only going to do once, like only this time. So I'm Anna. I have been a Node.js core contributor for a while now, nearly 4 years. I'm working at a company called Neoform, which is a Node.js consultancy company, and I work on a part called Neoform Research, which basically means I get to work on next generation features for Node.js. So currently that's mostly Quick, which is the protocol underneath HTTP3. So we're gonna have support for that in Node at some point. And yeah, I also did workers, which is like the one thing that if people know me for anything, it's that. Like, I didn't do it all by myself, but I pushed it quite a bit. So yeah, and I'm here because I like showing people how Node.js internals work. Because like when I first got into Node.js and started contributing to the project itself, like that was it was a whole new world for me. And maybe you can take away something from this talk. I hope you do. But yeah, so what am I going to live code? So we have a new feature in Node.js. It's called fs.opendir, or because we're trying to move people towards promiseified variants, fs.promises.opendir. And so it kind of works like fs.reader. If you've ever used that, it basically gives you a list of the entries in the directory. And so the difference to that is that fs.reader, it reads all the data in one go. Like you call the function, you wait for it to finish, and then you get a list of all the entries. And that works pretty well, but it's not really the Node.js way of doing things, because we try to, it's like, usually directories aren't that huge. Like I tried to run tried to look into it on my own laptop, and like 98% of directories or so have less than 30 entries. Like they're usually pretty small, but some are really big. And so in cases where you don't want to read all that in one single go, we have a new streaming variant for that. That is called this fs.opendir. It gives you a handle to the directory with like that you can iterate over using async iterators or other variants if you want to do that. And so it's like a streaming variant of that. And it was actually only released 2 weeks ago on this day. And I actually looked it up, and we actually did a Friday evening release. And the person who did their release is in our time zone, so I like to view that, like put it in a good light and say we have a lot of trust in our release process. Yeah. Okay, but so like people opened, like there was an issue opened pretty much right afterwards saying this is slow. And so like the original implementation only read over one entry at a time from the operating system. And especially when you're doing async operations, crossing the C++JS boundary, it comes with overhead. And we try to keep that as low as possible, but we just cannot avoid that at all. And so like one of the most common optimizations that we do in Node.js is actually to try and get rid of C++JS boundary crossings inside of Node.js. So like the original issue said 3 times slower. And so one thing that I already did was like bump that default from 1 entry at a time to 32 entries. Like that works pretty well because most directories have fewer entries than that. And it gave like 100 to 500% performance boost already. And so like the idea is, so you can always increase that number arbitrarily. And what you get is like, you get slower CPU usage because you have to read data less often actually. The downside is that you use more memory for one go. Like you could put that number through 1,000 and then you read 1,000 directory entries in one go. It's probably never going to be quite as fast as fs.reader in CPU usage terms, but that's not the point. The point is like we want to limit memory usage. And so what I want to do today is to actually make this number, this 32, configurable. And so for that, we're obviously going to have to modify the Node.js source code itself. And Node.js has quite a few layers. So first, when you call require fs in your code or import something from fs, what it actually does, it loads like the file lib/fs.js in the Node.js source tree. And that actually, it's like a regular module. It's nothing fancy, no C++ code involved or anything. We can look at that, and it looks like a standard Node.js module. In the case of OpenDare, the source code is sourced out into an internal file that you cannot require directly from outside of Node.js. That, in turn, reaches into C++. Because it has to interface with the operating system in some way, so we can't get rid of that part. It calls something called internal binding. That is kind of like require, except it only works for built-in modules of Node.js that come from C++ land. So like this is a typical pattern in Node.js. We implement stuff in C++, and then on top of that, we have a JS layer that contains all the public interfaces. The implementation for that is in a file called source/nodeder.cc, so like a C++ file. And that interacts with libui. And for the purposes of this talk, this is a black box. This is just a C library that interfaces with the operating system in some way that we're not going to care about. OK, cool. Let's get started. OK. So where do we start? So I said the implementation of this OpenDare function is in something called internal fs.dir.js. I think that's big enough for everybody to read. Yeah, I hope so. OK, so there's quite a bit of stuff in there, but let's start looking at the actual OpenDare functions. So we already take an options object there. This is good because we can just basically add options on top of that. And well, the interesting part is once we have opened the directory, we need to store the information of how many directory entries we want to read in one go somewhere. And for that, we take a look at this part. This is creating this new directory handle, and it's passing the options object to it. So we can extract that, hopefully, from the options. And so like I'm not actually sure that this is the right way to do it. But we have so many internal utilities for dealing with options objects, and this one particularly for file system operations options objects. And I'm just going to do this, and I'll open a PR later, and if it's wrong, somebody's going to tell me, right? So this is setting the default to 32, and it's copying the rest of the options, which has been modified through this magic get options thing. And so one thing that we'll need to do ahead of time is we'll need to add type checking, because we're going to pass this value to C++, and we typically don't do type check in C++. We just say, if this doesn't have the expected type, we're just going to crash, and that's OK. But I don't want Node to crash if somebody passes an invalid value. So we're actually going to check. So first of all, it should be a number. And it also should be an integer. And it also should be positive. Like passing in a negative value would not really make any sense. So if it's less equal than 0, then fail. OK, so what we're going to do, if any of these conditions are not fulfilled, we're going to throw an error. This is kind of like throw new type error, except that it's like it looks differently because we have this whole internal error system. Yeah. But it does the same as throw new type error. And we have the standard error type for that. OK, so now we have the buffer size option start in this variable. And now we actually need to pass it to the C++ line to tell it how many entries to read in one go. So for that, so this is the actual fun part. All of that you see on this part of the code, this is just overhead that deals with like the promise part of the implementation, like what to do if there's a callback, what to do if there's no callback, and it already reads the buffered entries if there are any. But yeah, let's go to the part where we actually call the C++ function. We're going to add an argument there. What the other arguments mean isn't really important at this point. OK, so we did that. Now we need to make the C++ part understand what I just did.
You're still missing a negation in the
You mean here? Yes, thank you. I mean, I would have noticed when I tried it, but this actually saves time, though, so thank you. And so one weird thing that C++ people do is like they split their implementations of things into two files, one that contains like declarations of things and one that contains the definitions. And yeah, I'm not going to go into too much detail on that, but the important part is here we have this thing where it says there's an array of 32 entries, and in C++ you cannot resize arrays. Like that just doesn't work. So what we're going to do, we're going to replace that with a vector, which is a lot more like a JS array. And we're going to fix the comment, because what would happen if we didn't? OK, we're going to so this is no longer valid. We don't know how many entries we read once when the directory handle is created. We only know that later when the actual read call happens. And OK, so there's a lot of code in there. This is actually how that native directory handle class gets created. This is how you create a JavaScript class from C++. And it doesn't look pretty, and it isn't pretty. But we can look at the important part, and that is, so this JavaScript class has a prototype method called read, which is where we passed in that option. If I'm going to find it again, yeah. So this is where we pass in that option as the second option. And we can see the actual name of that function is dir handle : read. OK, so first of all, we're going to have to account for the fact that I shifted the arguments by a bit. And again, update comments, because what would happen if I didn't? Yeah, I think this is everything. OK, and what we need to do now is to actually figure out what to do with this information. Because we know that it is an integer that is not negative, we can start in an unsigned integer type in C++. You have to know that in advance. And it's in the first argument if you start counting from 0. You may notice that I'm doing a weird thing when I'm typing a C, and that is because my C key just doesn't work. Yeah. So this is kind of like, this is how you extract values from JavaScript objects into C++ values. You kind of just get used to it. Yeah. One thing I need to do is I need to kind of import the number type from V8. I don't technically need to do that, but I could do it in another way. Then people would complain about that during code review, and I don't. Yeah. Okay. So the way I'm going to implement it is, if this buffer size option that we just received, that doesn't match the already existing length of this dir ends, vector array, then we're going to change that that size. Also, this is going to be it's going to fail horribly if you try to call .read on the directory handle like concurrently, but you shouldn't do that anyway. And if you use the async iterator versions, which you should do anyway, you're not going to have any problems with that. And it's already going to crash, I think, if you call .read concurrently. But you know, what are we going to do about that? Sorry. OK, and the next thing that we're going to do, so we have allocated space for the directory entries. The other thing we need to do is we actually need to tell the libuv handle. So I'm going to skip ahead of it. Right here. So this is where we told the libuv library where to store the directory entries and how many of them to read in one go. And we're going to need to update that as well. So the number of entries is our buffer size, and the number, like the where to store it, is this array that we just resized. And I think this should actually work already. I mean, there's a chance that it doesn't, you know. The nice thing about live coding C++ is that, like when you use TypeScript, it's just going to yell at me really early if I actually get something wrong. OK, so while that compiles, and hopefully it compiles as it should, one thing that I'm going to do in a couple of minutes is I'm going to run the benchmarks on that, because we don't really have tests. And what you're going to see is that we have benchmarks for the async, for the synchronous case, and for the case where you use a callback. So async is async iterator. And you're going to see that the synchronous version is significantly faster. Please don't take that to mean that you should use the synchronous version. Because the reason that you use asynchronous code is that operations can happen in parallel, and operations don't block your event loop. And the synchronous version does that. And with the asynchronous version, what the benchmark does, it only reads one directory entry at a time. But in a real-world application, using the asynchronous version means that other things can happen in the meantime. It's just even if it's half as fast, in a real-world application, it's still going to be faster than what you had originally if you use synchronous code. So yeah, please don't do that. Just a small warning. OK, let's see if this works. I'm going to start the Node.js REPL with, OK. So line 47. Yeah, OK. So the unfortunate thing about working with Node.js is that compiling actually takes a bit of time, and you kind of cannot get around that. But you know, this is still much faster than when you have to compile Node.js from scratch. Because I did it this morning to have an up-to-date copy of Node.js source tree, and compiling the V8 engine alone takes half an hour or so on my laptop. So that would take the entire time of this talk, which I'm not interested in doing. So OK. fs.promises.open there. we've got to use the largest directory that I know of, which is our test directory. Okay, so we start out with no buffered entries, which is okay. We read one entry. When we look at that now, okay, so there's a ton of buffered entries in there. Now let's check that our option actually works. So if actually, Peasant is much smaller, like 2. Again, no buffered entries to begin with. I call read once. And it actually has the entry that we read here that would be in this promise, and one more, so 2. So this works. That's cool. Like I said, so this is a feature that only affects performance, so we can't really test it, right? Like, we could look at this internal array here. That just gets ugly, and we don't want to get us logged into anything. So what we're actually going to do is to modify the benchmark instead, which is valid for these kinds of use cases. And we're going to add a few buffer size variants. So like one very small, one with the default. And like, yeah, let's take 1024 or something. I'm going to add that to all the calls where, to all the call sites of OpenDir. Oops. Okay, let's run that benchmark. Okay, I'm going to have to like scale this down a bit. What we can already see is like the version with buffer size 4 is slower than the others. That's kind of what we would expect. Yeah, I'm not going to go through these values in detail, but that's the important part. So this actually has an influence on performance. And you can also see that the larger the value gets, the less impactful a higher value actually becomes. Okay, cool. What else is missing? We added a new option to Node.js, so we need to document it. Otherwise, again, people are going to yell at you. So let's skip ahead to the OpenDir documentation. So I call this buffer size, and it's supposed to be a number, and has a default value of 32. I don't know, what does it do? It is the size of the internal buffer. That's like pretty accurate, I would say. And we can also tell people like, why would you use this option? We can say it's better general performance, but higher memory usage. Because we have OpenDir, and we have the synchronous version of that, and we have the promises version of it. We have to add it 3 times. Almost done now. One other thing that we do in Node.js, which I hope you like it if you actually ever use our documentation, is that we actually keep track of when we change something, when we introduce a new feature. And for that, we have this changes field in our documentation. I don't know in which version this is going to be released, but we use replace me for versions for the next possible version, and it actually gets replaced somewhat automatically during the release process. So that's neat. We also keep track of the PR URL where we added it. I don't know that yet. But this is just for our internal housekeeping, so we can look up more easily when something happened and why it happened. And so the description of the change is like pretty simple. I introduced a new option. And again, we need to do that for all of them. Which is, it's kind of unfortunate that for the file system documentation, we have to have all these duplicate entries, but I don't really know how to get around that. I'm also not going to run the full test suite like the issue template, the PR template says you should. Honestly, I never do that. because it takes like 5 minutes, and I'm just going to run the relevant test. And if something is wrong, CI is going to tell me, right? That's what it's there for. But yeah, cool. If the linter doesn't complain, then I think we're good. It's not going to say anything. Like when I get something wrong with regards to the linter, which probably happens more often than with tests, it's usually something in the JavaScript code where I have my own coding style, and that's not always what other people like. I am going to run the test file for this feature, though, because otherwise, well, I should do at least that. Cool, that still passes. Okay, so we're almost ready to do a PR. We have everything we needed to do. Okay, how do we describe this? I try to write good commit messages. That's kind of important to me. But I'm just going to keep this very straightforward here because I'm not sure what else to do. And because we had this issue for it, and this is currently the best kind of solution that we have for that, I'm also going to say this actually fixes this issue. Maybe it doesn't, but we can talk about that in the PR. I mean, like, the other thing that we would want to do is try to minimize the overhead of async operations in Node.js, and that's just like a very general problem, and nothing that we can apply to this specific issue. Okay, Wi-Fi, don't leave me. Cool. It's fast enough, right? And also, like, I'm done after this, so don't worry. Okay, so there's a ton of stuff in there, like the PR description, and then, well, please check that everything is okay. So obviously, the full test suite passed. We included benchmark changes. We added documentation, the commit message. I know how to write one for that. I also wrote this code myself. We can write open a pull request now. And so this is Script'19's very own pull request to Node.js. Who was that? Somebody's fast. Okay, yeah, I'm done. Thank you, everyone.